So our last topic in this unit is going to be, actually it's going to have two parts. We're going to determine different types of polygons on a coordinate plane, such as rectangle, square, parallelograms, rhombus, or kite. So if we're given the 4 points, we could tell on the coordinate plane which type of polygon it is, as well as if we know the type of polygon, such as a rectangle, square, parallelogram, rhombus, or kite, and we're given 3 of the 4 points that we could determine the 4th. Okay, so what we're going to go through and do first is list some of the different properties that these polygons all have. Rectangles, your opposite sides are equal. That doesn't look like an equal. And then when you get to math 2, we'll say congruent, but the opposite sides are the same. It has 4 right angles. Okay. Now a square has kind of the same thing. It has opposite. Basically, opposite sides are equal. It has 4 right angles. Okay, so between squares and rectangles, they both have these two properties the same. They both have opposite sides that are equal or congruent. They both have 4 right angles. The difference between the two, if you ever have these two options in multiple choice, is a square, all sides are equal. Okay, so that's really kind of the determining factor between those two, whether you're dealing with a rectangle or a square. Parallel lines, or parallelograms, your opposite sides are equal, and your opposite sides are parallel. Sorry, I'm just going to put the symbol for parallel. Okay. Now, opposite sides being parallel is actually the same in rectangles and squares as well. But generally, most people just talk about the opposite sides being the same because then you're going to have those 4 right angles. Alright, so the other two that are possible ones that you guys might see is a rhombus, and these, your opposite sides are equal, and your opposite sides are parallel. Actually, let me change that up just a little bit here, because your opposite sides are equal, but the distinguishing factor with the rhombus is all your sides are equal. Okay. Now, the only difference between a square and a rhombus is a square has the 4 right angles, okay, where a rhombus does not. All the other properties are the same in a rhombus. The main special thing is that all the sides are the same, just no right angles. Now, a kite is going to have 2 congruent sides, or 2 equal sides. And I'm going to draw an example of one of those. So in a kite, you'll have 2 sides that are, that make a vertex together, that would be the same. And then these 2 right here necessarily would be the same. And most of you should already know these properties to them. Again, most of the time, your answer choices are going to be rectangle, square, parallelogram, or rhombus. So if all the sides are the same length, it's either a square or rhombus. Then you just have to check for right angles. Parallelogram, again, is a lot like a rhombus. The only thing is your opposite sides are equal. They don't all have to be the same in a parallelogram. Just the opposite sides are going to be equal. And your opposite sides are going to be parallel to each other. Alright, so if you need anything from this screen, go ahead and get it. I'm going to switch screens. Okay, so with these types of problems, you're going to be given, they're not going to have them generally already plotted for you. I'm just trying to save time. But what they'll do is they'll give you 3 out of the 4 points, and they'll tell you what type of figure this is. Now, when you go through and it asks you to go through, like it actually gives you your 3 coordinates, once you plot those coordinates, go ahead and connect them in the order that you get them. It's going to help you to determine your type of figure. So, with this one, The first one is a parallelogram. So let's say if this point down here was given first, and the one on the bottom, that one was given second, and that one was given third. Okay, so when you get find the missing 4 points, plot the 3 given points, connect the first one to the second one to the third one, and that's going to help you be able to find your 4th point. Now we can tell by looking at this one that we know our 4th point, for this to be a parallelogram, it's going to have to be somewhere in this general region to it. So now what we need to do is figure out what that 4th point is. The easiest way to do this is we know the opposite sides are parallel. So if you just kind of follow the pattern, so I'm looking over here on this side. If I know, so if I start at this point, which is kind of the point that I'm dealing with over here, I had to go over 1 and I had to go down 1, 2, 3 to get to this point. So I had to go over 1 and down 3 to land on that point right there. Do the same thing on the other side. I'm going to have to go over 1 and down 1, 2, 3, which is going to put my point right there. So all you have to do is, in a parallelogram, just follow the same pattern from one side to the other, because they are the same length, which means that they're going to have the same kind of movement to them. So that right there is my new point. That one's at 1, 2, 3, 4, -2. And with that point, I then have a parallelogram. Okay, so these are always multiple choice. So what some students sometimes do is they'll just go through, they'll plot the 3 that are given, and then they'll test each of the 4 points, A, B, C, and D, and see which one actually makes the pattern work, which is just fine. Kind of up to you. Alright, so let's say this second one. We know it's a square, so all the sides are going to be the same, and I'm going to have 4 right angles. So let's say I had the one on the left first, to that one, and there's my 3rd one. So kind of again, I know that my 4th point is going to have to be somewhere in this region over here. Now I just got to find it. The nice thing again is, in order to find that next point, you can kind of just do the same kind of movement that you did before. Sorry, so I'm going to go through and look at the bottom. So I'm going to look down here and just kind of see what I'm doing to get there. So if I start at this point, I had to go up 2 and over 2. So I'm going to do the same thing from this point here. I'm up 2 and over 2. Okay. So if I follow that same pattern, there's my square. Okay, I'm going to get rid of some of that other highlight that I'd already put on there. Okay, so there's my square. Now, one of the other properties of a square is it does have to have right angles. Now, being able to determine a right angle, we actually talked about this just the other day when you guys were finding area of triangles. If you're going to determine a right angle, so I'm going to write this up here. Okay, hope if my pen didn't stick. Right angles have perpendicular slopes. Okay, so if you look at the slope of 2 sides that are trying to make a corner, if you just go through and find the slope of those real quick and they're perpendicular, opposite, and flip slopes, then it's automatically a right angle, which is a lot of times going to distinguish between a rhombus and a square, or a parallelogram and a square, or a rectangle, things like that. So I'm going to change my color just a little bit. Let's say I'm going to find this slope right here. Well, to go from this first point on the left to the point on the right, I have to go up 2 and over 2. So rise 2, run 2, which means that is a slope of 1. And let's say this side over here. Again, that one should have an opposite and flip slope, so it should be a -1. So if I go from the point on the left to the point at the bottom, I went down 2 and over 2, which is going to give me a slope of -1. So since 1 and -1 are perpendicular to each other, that automatically means that that corner is a right angle. Okay, so again, you just look at those slopes real quick if they're opposite and flipped. So This one, for my final answer, my fourth point is at 1, 2. Alright, so on this rectangle, again, let's say, I already have them plotted for us, but let's say that this one on the top left is our first point, and there's that one. So in order to find that fourth point, which I know is going to be somewhere kind of in this region, again, I just want to follow the pattern from the other side. So I'm going to look at this side over here. Well, from this bottom point, there it is, from that bottom point, I had to go to the left 1 and up 1, 2, 3. So from this point, I'm going to go left 1 and up 1, 2, 3. So there's my fourth point. I was at 1, 2, 3, 4. And I had to go up 1, 2, 3, 4, 5. So there's my missing fourth point. Again, I find those easier just going through and just finding the same side or doing the same thing on the other side. Again, those are going to be right angles. We could go through and check our slopes if we needed to. This side over here has a slope going down 3 over 1. So that's a negative 3 over 1 slope. And if I check this one over here, this one had to go up 2, and I had to run 1, 2, 3, 4, 5, 6, and 2 over 6 is the same thing as 1/3, so those are perpendicular, so it means I'm dealing with a right angle. Alright, so if you need anything from this page, go ahead and get it. Again, finding the missing fourth points I don't think are really too hard. Once you know the type of figure, just kind of copy the same thing that you have on that other side. Alright, so if you need anything, again, pause the video. I'm going to switch screens. We're going to try to determine figures. Okay, so on these, I didn't give you the points already drawn. So the problems that you'll get, you'll be given the order pairs and you'll have to draw them. So this first one's at negative 1, 0, which is, pen doesn't want to draw those. There we go. And then negative 3, 3. Just going to put me right there. 0, 5s over 0, 1, 2, 3, 4, 5 is going to put me right there. And 2, 2. So over 2, 1, 2. Okay. So if I connect those, just by glancing at it, it looks like it's probably a square. Now, it could be a parallelogram or a rhombus too, but kind of looks like a square. So first thing you want to check is you want to make sure the sides are the same. Basically, it has to be the same kind of movement going across. You can go through and do your distance form if you want to prove those sides. I usually just kind of count spaces, which I find just a little bit easier. So this side over here, to get from one point to the other, I had to go down 3 and over 2. So I'm going to check this side and see if I had to go down 3 and over 2. Down 3 over 2, and since I had to do the same movement, it means that those two sides are the same length. And I'm going to do the same kind of thing here. This one I had to rise 2, run 3, and this one down here I had to rise 2 and run 3. So that means all all 4 of these sides are exactly the same. So now I just want to go through and check, because that could be a rhombus, but for it to be a square, it's going to have right angles. I need to look at the slopes real quick. So, which colors a little bit. Alright, so let's say this one right here, I had to go down 1, 2, 3 and over 2. So negative 3 over 2. And let's say this one over here, I had to go up 2 and over 3. Those are perpendicular slopes, which automatically means I'm dealing with a right angle. That right there is a square. So when we go through and look at these, again, plot them in the order that you're given, connect them. Oftentimes you can kind of tell if it's right angles or not. I just kind of count spaces and determine if my side lengths are the same. And if I need to check if it's a right angle, I just check two sides where it makes a corner, check their slopes. If they're perpendicular, it's right angle. Alright, the second one is at negative 2, 1. Pen's not wanting to work. Negative 1, 3. 3, 1, just here. pen does not want to cooperate. And then 2, -1. Okay, so when I look at this figure, automatically, this is definitely not a square or a rhombus. All my sides are not the same. So this one looks like it's probably either, more than likely, a rectangle. Could also be a parallelogram if the corners are not 90 degrees. So in this one, again, just by looking at it, I'm going to tell if I have 90-degree angles. If I have 90 degrees, it's a rectangle. If I don't, it's a parallelogram. So I'm going to look at my slopes real quick. So let's say I want to look at this slope. This slope I had to go up 2 and over 1. So that's a 2 over 1. And let's say this one over here, I had to go down 2 and over 1, 2, 3, 4. Down 2 and over 4, which is the same thing as -1/2. So these right here are perpendicular. So that automatically means I'm dealing with a right angle. So this has to be a rectangle. Okay, so again, you can use kind of your visual and just kind of look. Whether it's a rectangle, in this case it looked like it. We just had to check slopes. Sure enough it is. Alright, so I'm going to try our fourth one. So this first point's at -3, 2. That's right there. 0, 4. Just here. 1, 3. And then -2, 1. Just right there. Alright. So again, looks like it could be either a rectangle or a parallelogram. Doesn't quite look like a right angles, but sometimes when you're drawing these it doesn't look perfect. So again, you want to go through and check your slopes. So if I check this one right here, that one is down 1 over 1, so it's a -1 over 1. If I check this one, I had to go up 2 and over 1, 2, 3. Those are not perpendicular to each other. So that means that is not a 90-degree angle. This one has to be a parallelogram. Okay. So hopefully that went through and made sense where we're looking at two different things. We want to, if we have 3 of the points, we need to be able to determine the 4th point. If we know what type of figure it is, or if we're given 4 coordinates, we can tell the different type of figure.